In this video, we are going to solve an equation for a variable that's also called literal equations. So that first equation we have, example one, where you have P equals 2 times L plus 2 times W. So this is your perimeter equation for a rectangle. It tells you the distance around. So you could think about like if you're putting a fence around your yard, the perimeter would be how much fence you would need to go around. Let's say we want to solve that for W. The process is going to work the same, only now we're not plugging numbers in. We have more than one variable. The goal is to get this variable by itself. So we have P equals 2L plus 2W. I want to start by isolating this term here. So I'm still thinking about my wall. I'm going to start drawing my wall again. There's my wall. The goal is to get this by itself. So what's on the side with that? Well, that 2L is over there, so we need to move it. To move it, I'm going to try to figure out how to zero it out. It's a positive 2L, so to zero it out, I'm going to subtract 2L. What I do to one side, I got to do to the other. So now those 2L's are going to cancel on the right, and that's going to leave me with just that 2W. And then here I have P minus 2L. And this has P's in it, this has L's in it. I can't put those together. So I'm just going to leave it as P minus 2L. And then now to get W by itself, I got to think about opposites. So we're thinking about peeling onions here in that first step by peeling away that layer of 2L. And now we're doing opposites. The relationship between the 2 and the W is multiplication. So now we're going to do the opposite and divide. Now, when I divide, I want you to notice I'm putting all of that P minus 2L over that 2. So I'm going to have W is equal to P minus 2L all over 2. And that's my answer for this. Let's look at the next one. We have V equals LWH. So that's the volume equation for like a rectangular prism. So think about the volume of a box. So you get a box from Amazon, and the volume is how much liquid could it hold. This is the volume equation. We want to solve for H. So I'm going to draw my wall again. And we're going to think about the relationship between all of these variables. I only have one term on the right, and that's that LWH. So to get H by itself, I've got to undo what's happening here. Well, right now it's multiplication. So to undo that multiplication, I'm going to do division. And all of these terms are multiplied together. So I'm going to move the L and W at the same time by dividing. What I do to that side, I've got to do to the other. So the L's and W's are going to go away. They're going to reduce. I'm going to have just a 1H or just H on the right. On the left, I'm going to have V divided by LW. So there's our answer. Let's look at the next one. We have 3x plus y is equal to 12. Say we want to solve that for y. So again, we're thinking about peeling layers. So I'm going to draw my wall. So to get y by itself, I've got to move that 3x. I'm going to zero it out by subtracting. 3x minus 3x is going to zero out. I just have y on the left. On the right, I have 12 minus 3x. I can't put these together. The 12 does not have an x, and the 3 does. So my final answer is just going to be y equals 12 minus 3x. And that's the equation of a line, and we'll talk more about that later. Let's look at a few more examples, and this is where you may want to try it, pause the video, come back and check your answer. So the first one, we have area equals 1/2 b times h. So that's the equation for area of a triangle. We want to get b by itself. So let's start with finding that least common denominator. So the least common denominator here is 2. So let's multiply everything by 2. So 2 times a is 2a. 2 times 1/2 would be 1 times b times h. And then now to get to get b by itself, we have to move the h, and we're going to divide. So b is going to be 2 times a divided by h. And let's look at that last one. We have y equals mx plus b. That is slope-intercept form of an equation. We'll talk about that more later in the course. We want to get m by itself. So we're going to think about that wall around my equals. And I'm peeling layers off. I want to get the m by itself. So to do that, I'm going to start by moving the b. That's that outside layer. So that b is going to zero out. I just have m times x on the right. Y minus b is just y minus b. Okay, they're different variables. I cannot put them together. To get m by itself, we got to move that x, and we got to think about that relationship. Right now they're multiplied, and the opposite of multiplying is dividing. That's going to zero those out. So we're going to have m on the right, and that's going to be equal to y minus b over x. So let's look at another one. Let's say we have a equals p plus prt. Maybe we want to solve for r. So this is where you may want to pause the video, come back, and then check your answer. So I'm going to start by drawing my wall. So I've got to get that term with the r by itself first. So to do that, I've got to move that plain old p. So, and to move it, I'm going to subtract. That's going to zero it out. So that p is now zeroed out. So I have a minus p on the left, and then I have PRT on the right. So notice on the right, everything's multiplied together, which means I'm going to divide the P and the T, and I can divide them both at the same time. And that's going to leave me with just that R. What I do to the right, I got to do to the left. So I'm dividing by the left by PT also. So I get A minus P over PT is equal to R. So that's how we solve literals.